Thank you for joining our webinar today. I'm Heather Gatney, and I'm the coordinator of the CVFS webinar series. Our host today is Emily Trelevin, Research Assistant Professor at the Survey Research Center at the University of Michigan. Emily is going to be presenting on CVFS relationship data. There will be a Q&A session after the presentation. We ask that you remain muted until then. During the Q&A, you may raise your hand to ask a question, or you can submit a question at any time today using the chat feature. We'd also like to inform you that this webinar is being recorded and will be available to view from the CVFS website, and we'll also put the slides up there later. So over to you, Emily.
All right, thank you so much, Heather. Hi, everyone. Thank you so much for joining today. I'm going to be presenting on the relationship grid and some history of CVFS that occurred before I joined the project as a co-investigator in 2017. So I've hopefully gotten all the details right. Bill and Dirga are going to be joining partway through. So I'll ask to hold questions to the end, and of course, we'll try to answer questions to the best of my ability. So again, thanks for joining. I'm going to present about the relationship grid, and then we should have some time for Q&A at the end, as well as some ideas to talk about potential ideas for data linkages using the CVFS data. I also will be I'll be talking some about merging data today. I gave a webinar in October 2021 called Linking CVFS Data that I will be also referencing and replicating some of the information from today as is relevant to talking about the relationship grid. So if you want to learn even more about merging CVFS data across files, across individuals, households, and neighborhoods, that is a great resource for further information there if I don't cover questions today. So I will first give a refresher on the CVFS sample, how it was selected, and then some relevant features for understanding the study and sample organization as is relevant to using the relationship grid and merging across individuals. I will briefly overview how CVFS files are organized at the household and individual levels, how they relate. And then talk about linking individuals across files using the relationship grid. What is it? What's included in it? And how do I use it? And then we'll have some time for Q&A. So starting with the sampling frame. For those that are less familiar with the Chitwan Valley Family Study, or CVFS, Chitwan is located in south central Nepal. So you can see here on this map of Nepal where the Chitwan district is, and it is bordered by the Royal Chitwan National Park and forest to the east and south, to the urban area of Narayangat and Bharatpur in the northeast, and then by rivers on the other areas. So it's really nicely geographically bordered by these geographic features. It's in the western part of the district. And on this figure from the 1999 population environment paper that was led by Ganesh Shivakoti, we can actually see the distribution of sampled neighborhoods across the study area. So again, we have forest, national park, and the river, and we can see that these neighborhoods are scattered across the valley, where this eastern third is more urban and becomes increasingly rural as you move farther west in the district. So when the study was designed in 1995, the geographic area was divided into clusters that each included 5 to 15 households. So they were of varying geographic size, but similar in the number of households that were included within those geographic boundaries. And all households in the study area were included in the sampling frame. So we drew these artificial boundaries. They first sampled 121 neighborhoods systematically, and then oversampled 10 neighborhoods to increase representation of specific ethnic groups, and then added other neighborhoods to the sample to reach a target of 5,000 individuals in 171 neighborhoods. So these 1995 and 1996 sample neighborhoods served the basis for the first individual and community level data collection that occurred in 1996. In 1997 was when the household registry started. So there were originally 171 neighborhoods and 5,000 individuals, as I said. But from 1997 onwards, due to budget constraints, 20 of the neighborhoods that were oversampled for that original 171 neighborhoods were dropped from the sample due to budget constraint. And all of those neighborhoods were in the middle strata, or this more peri-urban area in the middle of the valley. And so after that point, from 1997 onwards, individuals and households in those neighborhoods were no longer followed, leaving us with 151 neighborhoods from 1997 onwards. So the number of households in the geographic areas have changed over time. The geographic definition of these neighborhoods has not changed. That is, there's been no change in the boundaries. But because of movement in and out of the neighborhoods, the actual number of households that we now see in 2024 or at different time points over the CVS may be different. It may be less than 5 or more than 15. We also want to note that there were 2 neighborhoods that washed away due to flooding. Individuals and households in those 2 neighborhoods never returned to the original neighborhood after those floods, but we still include them in the sample and have continued to observe them after they moved to nearby neighborhoods. So in the data set, these households are still tracked over time. In 2008, there was a second round of individual interviews, along with some changes to who was included in the household registry system going forward. So from 2008 onwards, the household registry included all members of households in CVFS neighborhoods, regardless of their individual location. So any household that was within the boundaries of those 151 neighborhoods, all individuals in those households are included in the registry and continue to be followed even if they leave the CVFS neighborhood. And then the household registry continued to follow all individuals who were interviewed in 1996, unless the whole household moved out of a CVFS neighborhood before 2008. So in other words, if at least one household member was still remaining in a CVFS neighborhood, then all individuals in that person's household, even if they were no longer in Chitwan, continue to be included in the household registry going forward. For individual interviews in 2008, those included children and adults who were ages 12 to 34 that were currently in CVFS neighborhoods. If they were unmarried, their parents were included regardless of age. If they were married, their spouse was included regardless of age. We also included all individuals ages 35 to 59 in neighborhoods, and then anyone that was interviewed in 1996, regardless of where they were physically in 2008. And I want to point out that we have a frequently asked questions, or FAQ section on our website that answers questions about who is included in the sample and how that has changed over time. So that is also a good ongoing resource. And then finally, in 2016, CVFS also did an individual interview. And at that time, CVFS added all new households in CVFS households that were in CVFS neighborhoods to the registry. So these are households that were physically in the geographic boundaries of a CVFS sample neighborhood, but that had not been interviewed before. So these would be households that had moved into the neighborhood after 2008, where no individual was in CVFS. Households that already included someone in CVFS would have already been enrolled in the registry, and I'll talk more about that in a moment. So from 2016 onwards, it includes everyone that was already in the registry from 2008 onwards, and then added new samples, new households that had moved into CVFS neighborhoods into that sample. And in 2016, individual interviews were conducted with everyone in the registry that was age 15 to 59, regardless of their location. So that included individuals in that age range that were in CVFS neighborhoods, elsewhere in Nepal, or even elsewhere in Chitwan, as well as individuals in that age range outside of Nepal. So to summarize, I've talked about neighborhoods, households, and individuals as a part of the CVFS sample, and we can think of the sample as the set of all households in sampled neighborhoods and the study includes all individuals in those households, regardless of if they're physically in the household at the time of interview. So that means that we have people in the same household that are linked. So individuals are linked to households. Those households are linked to neighborhoods. Family members and residents in the same household are linked to each other. But CVFS follows individuals over time, regardless of location. So we have these linkages across space and time, reaching, even outside of the Chitwan Valley. And then I also want to point out that the CVFS uses a whole family design, and that means that there's no single head of household or reference individual in the household, so that we're thinking about everyone's relationship to everyone else in the household, not just how each individual is linked to a specific individual within the household, as is common in many panel studies. So just to further visualize our data structure, we have individuals that are nested within households and households that are nested within neighborhoods. So how do households enter the CVFS? You can enter the sample through moving into a sampled neighborhood. So your household moves into the geographic boundaries of one of the 151 neighborhoods. You can also form a new household by splitting off from a household that already exists in the study. So this would be when two or more individuals that are already enrolled in CVFS leave a defined CVFS household to form a new household. So an example of this might be if an adult child gets married and that child and their new spouse split off from their natal household to form their own new household. When two or more members leave to form a new household, they continue to carry their original respondent ID or individual level ID and get a new household ID. And their location may or may not change depending on where they physically move. It might be that they move into a new house on the same plot of land or somewhere else in the same neighborhood, or that they're moving to a different neighborhood or even outside of the CVFS study area. And then the only way that households leave the CVFS is through loss to follow-up, and that is when no household members are further tracked. Individuals in the CVFS can enter the sample through birth, through marriage. So if someone marries a CVFS respondent, then they will themselves become enrolled in the registry and become a respondent, or joining an existing household in another way. So they move into an existing household through a non-marital relationship. And then they can leave the sample through death or loss to follow up at an individual level. So generally, we've consistently applied these definitions over time, but I reviewed some changes to the sample definitions that occurred in 2008 and 2016. So over time, CVFS has maintained extraordinarily low rates of loss to follow-up for a panel study of this size. But given some of these changes and not 100% retention, if you're merging into individual level files from 1996 to 2008 or to 2016, we would still not expect to have a perfect one-to-one merge due to attrition and enrollment. I'll now provide a brief overview of the different types of individual and household data files that comprise CVFS, and then talk a bit about linking individuals across files. So many CVFS files are organized at the individual level. That is, the unit of observation in the data set is an individual person. So the first of these is the household registry, which is the dynamic panel of individuals over time of all ages, all individuals in all CVFS households. And the household registry includes various monthly level measures for each individual in a household, including their location. And I'll talk more about the registry in a moment. We also have individual interviews that are in-depth interviews that were done for a defined subsample at certain time points. Generally, all people in CVFS households between ages 15 to 59, so excluding children and older adults. Those were done in 1996, 2008, and 16. But we've also done other periodic surveys on specific health topics or other other areas of research with to find samples with other criteria. So for example, we've conducted child health surveys in 2016 and 2019 that were among all children under age 18 and among children under age 10 in 2023. There's the mental health survey that was among people ages 15 to 59. There have also been studies of time use, agricultural engagement, and then health and well-being among older adults, so looking at people above age 50. The individual interviews in 96, 2008, and 2016 included life history calendars, which are retrospective calendars collected collecting event histories of important life events. And then finally, the relationship grid maps how each individual in a household is related to each other. And we'll look at this in significantly more detail in a moment. So the household registry is a household interview to collect information about all individuals in a household, but the data are recorded at the individual level. So for some variables that are measured each month, some of those are going to be the same for everyone in the household. For example, where is the household physically located? But some of them might vary for individuals. For example, age, whether or not each individual is attending school in that given month, and individual's marital status. So we have monthly location measures for individual, as well as where the household is located, which is a variable called place. So those are different because location measures an individual's location. They may not be in their household in a given month, whereas place measures where the household itself is. And those are time varying at the monthly level over time. The household registry also includes a person's current household ID. So what is the ID of the house of the CVFS household to which they are currently associated with? A key for understanding how to merge observations across data files is understanding how IDs are structured. And the structure of IDs has changed over time. So I'll first review the prior structure that was used from 1996 to 2007, and then the current structure, which has been used since 2008 onwards, and how to convert in between. So we have three components of an ID in the Chitwan Valley Family Study. The first is a 3-digit neighborhood ID, ranging from 001 to 171, because in the original sample, there were those 171 neighborhoods. The second component is a household ID. So what number the household has within a given neighborhood. That was 2 digits in the earlier part of the study. And then a 2-digit individual ID. So to create unique individuals, and that would be 2 digits to which individual they were in a specific household. So to obtain unique individual IDs for each individual in the study, you append these 3 components of the ID to create a 7-digit respondent ID or RUSP ID. So for example, person 2 in household 5 in neighborhood 21 would have the ID 021, that's the 3-digit neighborhood component, 05 for the household, and then 02 for the individual. In 2008, CVFS moved to 9-digit ID structures. So this maintained the same 3-digit neighborhood ID component, but both the household and the individual components of the ID moved to 3 digits. So to convert, you add a 0 plus the 2 digits from the older ID for both the household and the individual components. So these can be used to create 6-digit household IDs. So that's neighborhood plus household for the household ID. And then a 9-person individual or respondent ID, that's neighborhood plus household plus individual. So following our example from the last slide with 7 digits, person 2 in household 5 of neighborhood 21 would have the ID 021 for the neighborhood, 005 for the household, 002 for the individual. And the household registry maintains a copy of the 7-digit ID, which would be RUSP ID _old, for individuals that were in the CVFS prior to 2008, as well as the current 9-digit RUSP ID for those individuals. So all individuals in the registry after 2008 had the 9-digit ID, but we've also recorded the 7-digit version for those that were in the registry prior. So an individual's household ID can be dynamic over time, as I mentioned before. So the household ID in the registry in a given month depends on what household that individual is a part of at that time. However, individual IDs or RESP ID never change. So once that is assigned to an individual, that ID will stay with them even if they move to a new household. So it can be the case that either the neighborhood or the household ID, those first 6 digits of a respondent's ID might be different than the first 6 digits of, than the current household ID that they are assigned in the registry. So that would indicate that that person had moved from the household where their original respondent ID was assigned. So for any given month, you'll want to look at the household registry to see what household that individual was a part of in a given month. And there's a monthly level time varying measure of household ID in the registry. So for example, if a child in the CVFS grows up, their 9-digit ID would have the 6 digits neighborhood and household from the household where they were born and enumerated into the study. And then eventually they may grow up, get married, and split off into their new household. At that time, their respondent ID would stay the same as when they were a child, but they'll be assigned a new household ID. So from that point forward, their household ID in the registry would differ from the household ID from their childhood home or their natal home. And the 6 digits of their household ID will differ than the first 6 digits of their respondent ID. So merging individuals to individuals, you'll first want to make sure that you're considering at what time the data was collected. So for 2008 and later, you can merge information about the same individual across data files based on their 9-digit respondent ID. For files earlier than 2008, depending on if both files are using the 7-digit ID, you can use the 7 digits, or you may need to convert the 7-digit ID to a 9-digit ID to be able to merge across files. So just to consider how many digits are in the respondent ID in the files that you are trying to merge. To merge another individual in the household or data set, you need to have a variable for each individual that contains the ID of the other individual you want to merge them to. And generally, these identifiers are going to come from the CVFS relationship grid. There are occasional exceptions to this. For example, in the child health data, we record the mother's ID directly into that data set. But for most cases, you'll need to use the relationship grid, which I'm going to discuss in detail in a moment. So examples of this would be linking spouses together, parents and children's, siblings, or other household members. So of course, it is possible to link individuals to themselves across files, but we are also able to link information about 2 individuals together using the relationship grid. And I just want to note, our top priority is to protect respondents, both their privacy with respect to what sort of consent forms they have signed, and protecting their identity. So we are considering that both in the information that we're showing you in this webinar, as well as what data we can publicly release through ISR, and then how we handle restricted use data through ICPSR, where our data is disseminated. So I will now move to talking about merging and the relationship grid in detail. So the CVFS relationship grid provides individual IDs by relationship type to every other individual in the same household. So it includes all members listed for a specific household ID in the household registry at a specific time point. So the registry is dynamic. It includes monthly level information over time. The relationship grids that we have reflect a specific time point. So it only includes information on the relationships within the household in that particular month. However, someone did not necessarily need to be physically present in the household at the time of the relationship grid to be included. It's just that they needed to be considered a member of that household. So that means everyone with a specific household ID in the registry in a given month, regardless of location, can be linked together. So in the relationship grid, we document various types of relationships. This includes spouses. Note that we record up to 3 spouses, although having 2 is very rare, and there was only 1 person that has 3 spouses, though those variables exist. Parents, children, siblings, grandparents, and then people with no relationship to other household members. At some time points, the relationship grid also includes the gender of each relationship. So that would be the gender of the person that is sibling 1, sibling 2, and so on. The gender of other relationships is not recorded at each relationship grid. However, for each individual, their age and gender is in each relationship grid, along with the total number of individuals in the household in that month, the total number of individuals in the household with no spousal, parent, child, or sibling relationships, the total number of individuals in the household with no relationship to other members, and then the household location in the month that the grid was generated. So we created these at 4 time points so far: 1996, 2001, 2008, and 2016. In theory, you could create a dynamic relationship grid for any month of the household registry starting in 2011 using available restricted use data of the household registry. Though these are the ones that we have generated so far. And then I want to note the time 1 or 1996 relationship grids are deposited and available at ICPSR. It's possible to find the links to that from our CVFS website. We link directly to the data files and then also provide the codebooks and questionnaires directly on our website. These are called files DS15 and DS16. We are working quickly to prepare the time 2, 3, and 4 relationship grids for deposit with ICPSR. We anticipate getting those done in the next few months without putting a specific time point on that. But it is out of our, once we deposit those with ICPSR, it is typically out of our control how quickly those are posted on their website for use. But we're happy to talk more about that if anyone is looking for further details. So this is a snapshot of what the relationship grid looks like, not the full set of variables, but I created one with scrambled IDs to protect our respondents. So this is not real data that we are looking at. This is using the 9-digit ID. So we can see a 6-digit household ID here. And then other IDs are the 9 digits. So it includes the 6-digit household ID along with the 3 digits for an individual. So for each observation in this data set is one individual in the CVFS identified with their unique ID or RESP ID. We also have their household ID, and then subject is a numbering of individuals in the household. It's the order in which they appear in the grid, but it does not necessarily correspond to their 3-digit individual component of their ID. So you don't want to simply add 2 zeros in front of this subject and then generate IDs that way. You want to look for the 9-digit respondent ID or the 6-digit household. So we can see subject 2 in this example actually has an ID that ends in 003. So that 003 is the individual component of their ID, not 002. After that, going across, each column here is a different kind of relationship. So we can see for the first person here, their spouse's ID is here, and then they have IDs for 3 children. Of course, a lack of information in spouse 2 and 3 would indicate there is no spouse 2 or spouse 3 in the household, and their parents are not in the household either. In line 2, we can see subject 1 spouse. So these are each other's spouse. And then again, IDs for the same 3 children. And then these 3 children are subjects 3, 4, and 5 here. And we can see their parent IDs listed, reflecting these first 2 people in this house. And as I said, this is a snapshot, so it's not meant to show all the variables in the grid. If we could see the sibling variables, then we would see siblings 1 and 2 for these 3 children, since there are 3 children in the household. So earlier in the presentation, I briefly reviewed some of the types of individual level data available in the CVFS. So if you want to merge information about one individual to another individual, for example, merging in information about spousal educational attainment, the first step is to obtain the ID of the spouse or the relationship of interest. So to pull in that ID, you'll want to merge the relationship grid with the data set of interest. So let's say the 2016 individual interview. And I'm going to caveat here that I'm talking about merging at a higher level, since CVFS data users work with various statistical programs. I'm coming from a Stata perspective. I know we have many SAS users, R users. So the particular merging terminology I use might be Stata specific, but this should be possible in all statistical programs. So you would do a one-to-one merge or an individual to individual level merge through using respondent ID with the individual level file of interest. So you would be merging the relationship grid using respondent ID to your target file. So this 2016 interview, and that will make it so that your spouse, parent, and child IDs, or whichever IDs you want to pull from the relationship grid, are now in your target or using data file. So again, you'll want to make sure that you have IDs that are in the same format. So 7 digits or 9 digits, be careful with, with the time period you're using. And then you'll also want to make sure that this RESP ID variable is in the same format and named the same across file, because occasionally it's all caps, capitalized, or all lowercase across different files. And now we have the relationship grid variables for each respondent in our individual interview file. So if we take this as our individual interview file, we see respondent ID, age, gender, this other variable one, and then now we can see the spouse ID for these respondents, as well as parent IDs and so forth. So continuing, for example, about merging in information about spouses, we can see that in the individual interview data set. And then relying on the spouse's ID as the merging variable, we can then pull information in about the spouse from a different file. So here, using our target or using file of interest, we'll want to make sure that the spouse ID variable, which we see here and here, is in the same format. So same number of digits, named the same. I might need to rename it in both files prior to the merge. And then here I've renamed it spouse ID so that it's easier to run a one-to-one merge. Caveating that, of course, not everyone in the master data set that we see here actually has a spouse, so you'll not have a perfect one-to-one merge for everyone. You'll have some observations in your master data for which there is no spouse, so no spousal information merges in. We can also use the relationship grid to merge information about a respondent's parents or children. So here we can see parent 1 and parent 2 variables for each respondent ID. So if their parents are living in the same household at the time of the relationship grid, we'll see an ID there. And if their parents are not in the household, of course, they are blank. But it's important to remember that our parent 1 and parent 2 variables are agnostic to which parent is a mother and which parent is a father. So we'll need to pull in information about parents' gender from other sources. So as I mentioned before, some of the grids have the gender of relationships included. So for example, the time 2 and time 3 grids from 2001 and 2008 have variables called gender P1 for parent 1 and gender P2 for parent 2. So we see the gender for parent 1 in this case is male, gender for parent 2 in these observations is female. So you could use this information within the file to figure out which parent is the mother and which parent is the father prior to merging. And then here we can generate mother ID and father ID variables based on that gender information. But in the absence of those variables, you'll need to use the gender variable for each individual in the relationship grid. So this is the case for the time 1 at 1996 and time 4 at 2016 grids. So let's say this, this person here, 212-007-011, is our focal individual in the data set, or person 3 from household 212-007. We can see, this is our focal individual, that this person has the same, we can see that their parent 1 has the same ID as the respondent ID in the line ahead of them. So this is our person of interest. We go to parent 1, and then we see that this is parent 1 here. And then we can see that this respondent ID, who is parent 1 for this person, is female. So that would be the focal person's mother. So once we know it's the child's mother or father, then we can create a mother ID, father ID, and merge to individual data sets the same way that we did it for spouses. And then turning to sibling merges, the same thing. I'm showing some different variables here. We now have SIB1, SIB2, SIB3, and SIB4, and we can see the IDs for each sibling of our respondent or individual of interest. So similarly, we can do a merge for pulling in the siblings unique IDs, and then pull in information by merging on the siblings ID in the same way that we did for spouses. So using the CVFS relationship grid, since it documents spouses, parents, grandparents, and other relationships, opens up a lot of possibilities for intergenerational and sibling design. So it's easy to pull together information about spouses or couples. We can also pull together information about parent-child dyads, so looking at one parent and one child together, as well as parent and child triads, so looking at two parents and a child together, as well as grandparents and grandchildren, or even grandparent, parent, grandchild triad, so across 3 generations, and then of course, siblings. So CVFS investigators have done quite a bit of work looking at spouses and couples. We wanted to highlight a few more recent papers looking at spousal or couple level relationships. We have papers that have looked at contraceptive use and spousal educational attainment, marital quality and labor migration, and then consequences of migration on spouses that are remaining in households of origin when another spouse migrates. We also have papers that have looked at parent-child dyads. So both where the young children are the focus and looking at information about their mothers and maternal employment and child educational outcomes, as well as looking at adult children and their parents, looking at adults' education and then older parent mortality. And then many CVFS papers have looked at parent-child triads, so looking at effects of both mothers and fathers and how those have shaped children's outcomes, looking at parental mental health and children's marital outcomes, looking at parents' marital quality and child outcomes, and then looking at parental attitudes and children's marital outcomes. So there are many possibilities. You'll notice that we don't have example papers on sibling designs, but that is very much possible. So we think it would be a great area of future investigation and a great way to leverage our rich data. And I will end my presentation there and we can move to Q&A. Thank you.
Thank you, Emily. I'm so sorry I was late, and I'm so glad that we put up a bunch of papers written by Elise Jennings and Sarah Browner Otto. Like, imagine how dumb we'd feel if we hadn't done that.
I did not look at the registration list either.
Yeah, we didn't know that ahead of time, you guys. It wasn't based
I promise this was not pandering.
Yeah. Well, not that we wouldn't, but just not in this case.
I think the real question is like, what does it mean that Elise and I have written these papers, and yet we are the ones here learning, trying to learn more or again about linking?
Well, I mean, let me take the positive interpretation of that and try it on you guys, which is there's, from what you've already managed to do, how much more could be done. And it takes a lot of work. I think a lot of people, and one thing that I don't know, I'm curious about people's input on this, and you guys should be asking questions, not me, but I'm curious about people's input on, what kind of linked data file releases would the next generation of scientists find most useful, where people would get, more mileage out if we did some of the work ahead of time. But we basically do work to a project. And then each one of these to do it really well, of course, takes so much work. And I think both of you have some direct experience with that.
I was going to ask, this was really helpful. Thank you. I always learn something new when I attend these webinars, and I talk to people who are more actively currently using the data. I was wondering if you are planning to release any code along with the release of the relationship grid data files that would help people, know the best way to do these linkages. Code that they could just kind of use so that we're all doing it correctly.
That's a great idea, Lisa. I don't think we've actually talked specifically about that idea, but I think it's pretty straightforward to at least write up a few examples like the ones that I used here. And we should, in theory, be able to pull enough of us working across different softwares to have SAS, data, R code.
There's some limits because we gotta pay for the effort to do it. But I think if we could even get some input from you guys about priorities, I don't know. I mean, if you've already thought them through, Emily, that seems like a good head start on asking for a specific piece of code.
Well, I think like what I described is fairly straightforward to do, but I think there are easy ways to make it go wrong. So I think even writing up one example that, isn't probably more than, well, I don't want to say how many lines of code, but it's simpler, at least in Stata, it's simpler than it sounds. But it's also easy to make mistakes. So I think it's relatively easy. Looking at examples like from the DHS where they, provide sample code for here's how to do our survey weights, et cetera. They're not long, they're not complex, but they do help people avoid mistakes that could otherwise be easy to make.
Yeah, I think that's a good point. I think IPUMS is also tending to release some kind of standard codes too. So this might help make the CVFS more user-friendly in that way. My question is one where I'm pretty sure I know the answer to, but I'm going to ask it anyway. Where are we in terms of linking children to their correct lines in a parent's life history calendar about their children's life events?
That's a great question. I've never tried to do that.
I've never heard that one before. I mean, it makes a ton of sense, but
because we've tried and we've not been very successful. You try to guess age and sex and things like that to try to make the best possible merge, but it's pretty incomplete. But it really extends the information that you know.
Of course. No, Young Zhang did a bunch of work when we were working on mental health to get marital history data for people who weren't in the registry system. So, people who joined the sample recently, just before that mental health interview, so we could link their own individual marital and childbearing events to then the risk of them having a mental disorder. That was a huge project by itself, but I think that's a lot easier because I don't know what Deirdre will say about this, but well, first of all, we know the household registry ages are imprecise. No one, and I don't know either whether we should put like a warning label on wherever you log in to get those data, but everybody who uses it knows that it's got the system adds 1 year to their age at a particular day of a month once a year. So, okay, rounding error, boom. It's often the young child's birthday is provided by somebody else, a household respondent to begin with. So, okay, that's more rounding, boom. And you add 2 types of rounding and you go from, well, this could be off by 1 year to 2 or 3 years in either direction. Then if you have very much fertility, like unless you had 2 kids in the parent life history count, you got 2 kids, 1 male, 1 female, we only have documentation of 8 cases who've changed their gender identity in CVFS. So if you had, 1 of each, I could see getting it done. But around the time you've got like 3 boys within 2 years of each other, oh my, that sounds tough.
Yeah. Okay.
It's a great discussion question for us. So
No, because it would,
I
again, it's
appreciate the
great.
flag.
Yeah, it would really improve the retrospective data for sure, right? Because you'd be able to look backward more, and I would say, that was funded, I think when Young Zhang did the work she did for us, maybe at whatever, a graduate student research assistant type of level of cost, but 6 months to do that one.
Mhm.
So, there's so many cool things we could do, which I always am like, can we do this if we don't have a funded project to do that thing? I don't know. But we do aspire to use the R25 money from NIH to keep chipping away at it. One good, bad thing we've had in the last few years is we're producing new kinds of data at a faster rate than, if we go 5-6 years without any new data sets being collected, we get a lot of time to do linking. But also we got a bunch of new data sets. Now we're doing code books and documentation, and it's a very interesting problem.
Okay.
How's that for a non-answer?
No, I think it's just one more way of linking, that like one more thing we have that we haven't quite been able to fully exploit.
Yeah.
That's all.
No, there's so many kinds of within the household linking that make geocoding look good.
Yeah.
Latitude, longitude looks like a piece of cake now to me, compared to some of this stuff. I know it wasn't at the time, but you know what I mean? Like stuff is hard. But I think if we know from our user base what they want, that helps us work toward getting money to do it. If I don't know, Emily, do I say this every time we do a webinar and I start to talk? Anybody wants to write a proposal doing this, we're happy to help. Because it would be a great product for everybody.
I don't have any more questions.
I have a question that's not so much about the relationship grid itself, but you mentioned that 2 of the neighborhoods got washed away by floods, which I didn't know. When did that happen, and how do you handle that in your analyses, if at all?
So the actual, if you were to look for individuals from those neighborhoods in the registry, they're still there. You'll see that they're in their location has changed, either in individual and household. Actually, location would have both changed after the flood. I don't actually know when those events happened. Deirdre, can you comment on that? You're muted.
I don't remember on top of my head, but I have those date written somewhere. I could.
Jenny did mention 2017.
Oh,
Jenny Williams. Yeah.
Thank you, Jenny.
Okay,
Yeah.
that makes me feel less bad that I didn't know about it, because it's
Yeah.
been since I did the data that I was using. Okay.
So typically, if you just look where their current location is and then handle that analytically, however would be most appropriate for what the research question is.
Sure. Okay. Thanks.
Any other questions?
these sessions are recorded for long-term use. So I was reluctant to say, please don't forget to tell anybody who's interested to join us at PAA from 3 to 5, wherever it will be. Because I was like, well, you're looking at this, a month after PAA, what good is it to mention that here? But as long as
That's on Thursday.
It's Wednesday 3 to 5. It's the Madison room. I wrote that down so I could share it. And you're right, Bill, I did not announce that at the beginning. So yes, it's a informal drop-in session. Bill, Dirga, Coulter, Uttam and Heather will all be there. Bill, jump in. I was going to say, we're happy to answer questions, troubleshoot data problems, chat with students that are working on things, chat about new ideas.
Or maybe Sarah shows up and we just sit there trying to figure out how the heck would we link life history calendars to, like we could, mom's life history, like we could just do that for a couple hours. That's an option.
I have one question. So siblings seems pretty straightforward because they're going to have the same parents, assuming that they were kids in a household at one point in time, and you can trace them forward, right?
Yep.
So then we can get cousins because we can look at their children.
Mm.
I mean,
Yeah.
one of you might know this better than me. I mean, my memory is something like 10% of the
Wait,
households had 2 wives.
Let her have to finish. Yeah, go ahead, Sarah. Yeah.
Yeah, so I'm just wondering, like, how select is this cousin grouping, right? This is me explaining you guys to think through this problem, right? So if we start in like 1996, we have families, they have kids in the household. Those kids are always in these data, right? So you could make a data set of like siblings, cousins. They would all have the same grandparents. And presumably it wouldn't just be like stayers, right? No, because kids of initial respondents are not followed, only initial respondents.
It depends on, I believe, please correct me if I'm wrong, someone, but it would depend on the timing of when they left the natal home. So if they left and moved out before 2008, then they probably were not followed. If they left in, say, 2017, that they're potentially still all in there.
Yeah.
Yeah.
Right.
Okay. And I'm right that to connect cousins and like other sorts of extended family members, we just have to build this out. Like it's just
There are several more steps, like who is the brother of whom, and how their children. Yeah, it has several steps. Like you can do that. You should be able to do. Yeah.
okay. Okay.
What's your may I ask what's your rationale to do that?
I'm just trying to think about like, I don't know, kind of thinking of multi-generationally and what do we really have in these data, like how many generations realistically can we track, and then what are the relationships like that when you get to that third level, like how many are really related to one another.
Right.
Things.
Yeah, my head was, are we going to define the household as, from that? And like, there are, one household is the grandparents, parents, and children. So it is, same generation, 3-generation household. And other one is grandparents, two parents, and then their kids. And it is 3-generation, but it's a different kind, right?
Yeah.
Yep.
Okay.
Yep. Sounds good. I will keep thinking about how we can code the life history calendar. I think The mother, it only has a mother's, the children information is only in mother's life history calendar. And there should be way to figure out some ways. I will have to think through.
Okay.